25. This is Mr. Lewis, Mr. Lewis,
Yeah.
and I am
Go with
Mr. Miller.
Lewis.
And
Yep.
today we're talking about data transformations.
All right, let's hit it. So, data transformations.
What's a transformation?
Transformations when something changes.
Yeah, so like a personal transformation would be like a makeover?
Yeah. Or, get a haircut, change into something. Or maybe you morph personality-wise.
Yeah.
Become really depressed. Let's not have that here.
Dr. Jekyll, Mr. Hyde kind of thing?
Yeah, exactly.
Right, that's a transformation. So this is a data transformation. So we're going to do something to the data. And we have to understand how the statistics change. So on the left, Mr. Lewis, we have a lovely dot plot.
Yes, we do.
That's our original data. You want to put the original? That's the original recipe. So
original.
Very good. And we're going to add 5 to all the data values and see what happens. So the second graph, we've added 5 to all the data values. And what happened?
Well, it shifted. Looked like it shifted. Probably we were at 3, moved to 8. Looks like it all shifted 5.
Yep.
Which would make sense.
Yeah, so the shape didn't change.
Nope.
Did it get more spread out?
No, it did not.
Yeah, so when we add 5, the spread doesn't change. So the measures of spread should be the same. All right, for the original data, we got to calculate the mean, the standard deviation, and the IQR. So Mr. Lewis is going to read that off to me.
All right.
And what do you have?
3.
Yes.
3.
Yeah.
3.5. 3.5. 3.5. 3.5. 4. 4. 4. 4.
Yes.
4.5. 4.5.
All right, here we go. We're going to need these a couple times. So stat, calculate. One variable stats. All good.
Stats.
The mean is 3.75.
0.75.
The standard deviation is 0.5.
0.5.
The median is 3.75. Oh, how could I have known that, by the way?
Probably because it's very, very symmetrical.
Yeah, true. And the IQR is 0.5.
0.5. Okay.
Interesting. That's weird. IQR and standard deviation are the same. That's a fluke.
Yeah.
There's no fluke that the mean and the median are the same because it's symmetrical. But the standard deviation and IQR are working out to be the same. That's just weird. All right. So when we add 5, we see that the measures of spread stay the same because the data didn't get more spread out.
No.
So over here on the right, we can just copy what we had before for the standard deviation. That should be the same. And same for the IQR.
Yep.
However, measures of position, like mean and median, and also Q1, Q3, those guys, they went up by 5. So when we add 5 to all the data values, the average went up by 5. So the new average should be 8.75.
0.75.
And the new median would be
8.75.
Okay, so this is a rule we got to remember. When we add 5, the data values don't get more spread out.
Right.
All right, so when we add just a number, spread stays the same, but measures of position change.
Exactly.
All right, let's do something else.
All right, so now we're subtracting.
Oh, it scooched to the left a little bit.
Yes, it
So
did.
the original data said they look the same, but if you notice carefully in the second graph, they went to the left.
Yes.
They went 3 to the left.
They did.
So addition and subtraction kind of work the same way. So the original mean was 3.75.
Yep.
We have 0.5 for the standard deviation.
0.5.
These are our starting values all the time. 3.75.
0.5 and 3.75.
Now, over here, we don't have x anymore. We have x minus 3.
Right.
So the new mean should be 0.75. We just subtract 3. Standard deviation should be the same. The new median would be 0.75. And the new IQR, same as the old one.
Crazy.
So adding, subtracting just shifts the data.
Yes.
Okay.
That's exactly right.
Time for something else.
We're multiplying.
Now, multiplication affects everything.
Yes.
So we see not only did the values move to the right, they also got more spread out. So when you multiply by 3, everything gets multiplied by 3.
Correct.
All right. So the old mean was 3.75.
3.75.
Then we have 0.5.
0.5.
3.75.
3.75.
And 0.5.
0.5.
Everything gets affected by multiplication. So the new mean would be 3.75 times 3 is 11.25.
2.5. I don't know why I was going to do a 7.
The new standard deviation would be 0.5 times 3. It's spread out by a factor of 3. So in algebra, this was a stretch. Sometimes you did graphs. You did shrinks or stretches when you transform functions.
Correct.
It's kind of the same thing with data. This was a stretch.
Yes.
All right, so the new median would be 11.25, 3 times the old one, and the new IQR?
1.5.
Got it.
All right.
All right, let's go to the next
We're getting
slide.
the hang of this.
By the way, one last point. Division works the same way. Multiplication and division are related.
Yes.
So if we divided by a value, excuse me,
Bless you.
everything would change. All right, here we go.
Okay. So here we have a chart of fun stuff. Here we only are given the mean and the standard deviation. We're given what action, so we want to find the new stuff. So here we had a mean of 4. If we add 6 to that, our new mean would be
10.
10.
Old man's got this.
Yes. Our standard deviation of 1.5, we added 6, but
7.
when we add, nothing happens to that standard deviation.
Oh, I forgot. It doesn't get more spread out, so you just got to remember.
Just 1.5.
Okay.
Mean of 30, if I multiply that by 2, our mean would now be 60.
Right.
Our standard deviation, now this is affected because we are multiplying.
It stretches the data out.
And so we're there 12.
Okay.
Our mean of 24, divide now by 4. Our mean would be 6.
Right.
And our standard deviation of 10, we're dividing by 4. Our standard deviation is going to shrink.
Right.
Right. So this should be 2.5.
Yeah, so if multiplication stretches the data out, we'd expect that dividing by a number bigger than 1 would shrink it.
Correct.
Okay.
All right, and then 12, subtracted 9, would be 3. Standard deviation of 2, subtract 9, nothing happens because I'm subtracting.
Cool. All right. That's basically what we have to know about data transformations.
Yeah.
The effect of adding, multiplying, dividing, and subtracting. Sometimes we'll have a combination, but not yet. So let's hit it. All right, we've got a few more. Now this is median and IQR.
Okay. So our median was 4. We're adding 12. So our new median would be 16.
Yeah, it's a measure of position. It's a measure of center. So measures of position are going to change.
Right. And then at 1.5, add 12. Well, we're adding, so we are still at 1.5.
Because IQR is a measure of?
Spread.
Yeah. Okay, good.
All right. Median's 15. Subtract 5. New median, 10.
Mm-hmm.
IQR 18. Subtract 5. Our spread does not change. We are left with 18.
All right.
Median 67. We're going to multiply that by 3. Be 100 or 211. Oh, 1. I was off by 10. Mental math took a break today.
That's right.
IQR 104. Multiply that by 3. Should be 312.
Wow.
All right. Got back on the horse.
Young and sharp. Okay.
All right. Because now our data did spread out, just like Mr. Miller is telling us.
Okay.
All right. I think it's time for them to practice on their own.
It is. Here you go.
All right. So here we gave you a summary statistics for a set of data. So our mean, median, mode, all were listed. I'm sorry, not mode. Standard deviation and IQR.
You've been in the freshie building too long.
I know. It's just multiple things happening at one
That's all
time.
I'm talking about. Mean, median, mode. That's it.
All right. So in A, we want you to suppose each value is increased by 10. B, we want to divide by 2. And then C, tell us if there's any evidence that this data would be skewed, either right, left, or symmetrical.
You mean they're supposed to remember stuff from last unit?
Yeah, I think that's the general idea.
Okay. Let's see if they got it.
All right. So, good luck, guys.